and he has been very active in the regional science community for quite a while now. I won't say for how long, but quite a while that we have known each other. In fact, we met at the European Regional Science Conference. And Davide's research interests are many, so including economic growth, nonlinear dynamics, regional policy, spatial econometrics, wealth distribution, social mobility, migration, which is something that we have in common and we were planning to work on together, and even corporate social responsibility. And today, Davide will talk to us about the geography of population distribution dynamics, with particular reference to the case of Italian municipality. Thank you very much, Davide, for accepting our invitation. We are very happy to have you here. The rules of the game. You have up to 1 hour to present. Okay. Better if it's a little bit shorter, so we have more time to interact.
Okay, thank you for the invitation. I'm sorry for this slight change in the title. Now is population is not income. And I think that the explanation should be clear in a few minutes, okay? So this is joint work with Angela Parenti and Cristiano Ricci. Cristiano is a postdoc at the University of Pisa, and Angela now is assistant researcher, again at the University of Pisa. So just to motivate, okay, my seminar, and in general, we discovered that we have a sort of two contribution or two approach to the issues. I think that it's quite familiar for several of you, but this is the population at the municipal level, okay, in Italy in 2 years. The first is 1982, okay, and the second one is 2019. So I use these 2 years because it's possible to have a sort of a comparison between the municipalities at the beginning of a period at the end. And it's strange, but there is some dynamics in the definition of municipalities in Italy, okay? And I think that it's quite difficult to have an idea of the dynamics, or if there is a dynamics, because it's a bit messy, yeah? And maybe it's useful to take not just is starting as loop is okay, is by chance. Maybe the first step in the analysis is not to consider population, but the population density. Why this? Because it's not clear from the picture, but the areas of Italian municipalities are really heterogeneous. And so population density maybe is a way to take the first step in the analysis. And this picture is exactly the previous picture, but with the dynamics. And what is this is exactly a contour plot, okay? And where the red is the maximum density, and the yellow, the blue is the lowest density. It's clear that we can, we can identify, for example, Naples here, Rome here, and Milan is here. And you see that if we follow the change in the year, you discover what? We discover that this is a typical, very slow motion dynamics here, or the time scale of dynamics is very slow. So when you observe this jump is because that is at the end of period and then we start again. And so in other words, if you are interested to the distribution dynamics of a population, you have to take 40 years. Otherwise, you have no dynamics first. The second is if you observe this picture, maybe because there is red, okay, against yellow, against blue or light blue, we discover what? We discover that the geographical pattern of Italian municipalities or Italian cities is really heterogeneous. And I'm sorry, but I use the mouse. Okay, you see that what? You see that you have, for example, the peak of a population density is around Naples. But we know, for example, that this peak is not mirrored by the peak in income. This is quite different, for example, for with respect to France. With respect to France, or with respect to other countries. I think, for example, US, when there is a sort of correspondence between population density and income per capita or per worker. And we also observe, but maybe is not so clear, that there is also different patterns over time. So with respect to other countries and with respect to different regions in Italy. For example, we observe, for example, Rome, the population density is declining over time. And is not the same for Naples or the same, for example, for Milan. And there are a large part of Italy, in particular, you see the coast here is Liguria and Tuscany, but also the Veneto and Friuli Venezia Giulia. We observe a very different pattern population density. Maybe we know because we are Italian, but it's not so standard at a European level, in this pattern. And so this, I think this is my first motivation. So how is possible to formulate a model on the basis of this? Yeah, and I think that the next step is not just to consider municipalities, but to consider local labor market. Maybe we know, you know that, for example, in US we have the definition of metropolitan statistical areas. In Italy, the name is Sistemi Locali del Lavoro. Translation, official translation, local labor areas. Just to be sure that, okay. And why is it so important this? Because it's clear that municipalities is a sort of administrative definition. And maybe when you take a sort of continuous process in terms that it's clear that the location is more or less in the continuous space, but you divide this space in the administrative areas, maybe you can insert a bias in the estimate. The bias can be maybe controlled or maybe can be attenuated by using the local labor areas. And so in this picture, now the borders are not the borders of municipalities, but the borders are the borders of local labor areas. And I think that this is more clear that in some sense there are very different way of dynamics in some sense, or very different pattern, no? Because again, you have a pattern of very concentrated here around Milan. I'm sorry if maybe it's, oh, sorry, I'll take another picture about Milan and about Naples. Naples is here, okay? And Rome, if you look at Rome, it's very, very flat, the distribution of population. Also, if you consider the local labor areas, sorry, okay. And you also observe that there is some dynamics, and in particular, if you look at here, you see that the green is more intensive. So this means that there is an increase in the density there, okay? And it's not the same around Rome or around Naples. So I think that, okay, maybe this is just a suggestive evidence, but I think that it's really important that, in other words, the motivation to study Italian population or the population of Italian municipalities is exactly there. Complex landscape, yeah, very heterogeneous patterns, geographical patterns, and maybe the explanation is not so simple, yeah? Okay. If you are familiar with spatial econometrics, maybe you are familiar with the Moran scatter plot, which is the Moran scatter plot. Is exactly a sort of representation of what? On the x-axis, you have the population The population density. I'm sorry, okay, it's here. And the other axis, you report a sort of a measure of the density around this unit of observation. It's clear that the key point here is how can I define my neighbors? In this case, I think that the best definition is the municipalities in the same local labor market. And if you take this, and I report also the so-called big cities, big for Italy, but not big for at the international level. And I'm sorry, the names are in Italian. You get a picture really interesting for me, but maybe I don't know if it's so clear at the first sight. And in particular, you get what? But you get that there is a distribution along the first bisector. So this means that what? Big cities or cities with a higher density are correlated in a local labor market with the municipalities with high densities. I think that this is not a surprise. But if you consider the red line, and the red line is this, you get that the red line is a sort of average relationship between my density and the average density of my neighbors in the same local labor areas. You get that there is some differences among the cities. In particular, I'm really interested to Naples or Napoli against Milan and against Torino, you see here, and other cities, maybe not so big as, for example, Catania here, and there is also Venezia is here. I'm sorry, it's terrible, okay? When you are along the bisector, your density, as for example, for Catania here or Venezia here, is exactly the same density of your local labor market. So you should be thinking about this, about a sort of homogeneity in population density in your local labor market. It's quite difficult in this case to think about a sort of cities with a downtown and the sprawling of your cities. When you take, for example, Milan or Naples, you get exactly this information. It's very far, yeah, and the neighboring municipalities in the same local labor market are very heterogeneous. And so this means that you have a downtown and then other, okay, other densities in your neighboring municipalities. But, surprise, you have also a list of cities, for example, Bologna, for example, they are really important, Bologna or Florence and so on, that are not following this because they are below the average. So this means that our intuition about a different geographical pattern is just, you can be, I don't know if validated, okay, through this Moran scatter plot. Yeah, and I think that it's quite interesting for us, and this is not so easy to grasp at the first sight, but it's exactly the same Moran scatter plot, but taking as a dynamic approach. In other words, you have exactly the same Moran scatter plot, and for each point you consider, for each arrow, you calculate the dynamics of our municipalities from 1982 to 2019. What is the point here? Okay, technically this is a random vector field because this means that there is a local estimate of the direction. Why we are so interested? We are so interested because we are interested to think about if there is a sort of a common pattern in terms of the dynamics. You remember there, we just look at a sort of photos, But now we're interested to dynamics. And we observe that there are a sort of 2 points or 2 loci, here and here. And here there is, for example, Milan and Naples. Yeah. And you see that there is a sort of natural dynamics here to increase in this direction, which is the meaning of this. This dynamics means that the municipalities taking the same population density, but the neighbors are increasing the population density. So this means that you have a sort of diffusion. Yeah. Yeah. And this is, I think that's another story and about the need to take a sort of very, very, the technical term is not parametric approach to the study of this phenomenon. So this means that the local dynamics is really important. It's quite difficult to think about just one pattern, you know? And just to conclude this part, if you look here, what is the point here? The point is are the neighbors of really low populated municipalities. And this is a part of the, I think that the part of Italy with very, very small in terms of population municipalities with very, very low populated neighbors. And maybe you know that the number of municipalities in Italy is very huge. And this means that, in other words, that municipalities maybe are municipalities just by definition, in terms of administrative definition. And it's not a true municipalities in terms of in terms of economic dynamics, in some sense, or population dynamics. Okay, so this is a sort of very, very brief illustration of the dynamics of population and municipal level in Italy. And here there is a sort of list of comments or remarks on our very, very brief summary of the dynamics. Yeah, and I think that okay, it's just a summary. I think that it's more or less interesting. Yeah, okay. So in the second part, now we try to formulate a model, a theoretical model. I know that this, okay, I know that this part is not boring, but it's very tough in some sense because it's not standard approach we use. Okay, and I hope that you take the main ideas. I'm really interested to your feedback because it's more or less the first time I present this. It is a part of a long-run project on formulation of a model for the population dynamics, for the dynamics of the population, I think in Italy, but also another part. So let me just list the key ingredients taken from the literature, it's clear. The first, I think, is that this should be a model based on agents. So I think that it's quite difficult to find a sort of macro model if you are interested in explaining this phenomenon. And our approach is that to take this agent-based model, this typical approach used also in macro literature, and then to take this and to try to formulate by this model a sort of synthetic description of the dynamics through a partial differential equation. Okay, I think that, okay, I was not very familiar with the partial differential equation, more or less until 3 years ago. So I think that's a novelty also for me, and I hope that I will be, I don't know, clear about this, okay. But I'm more expert in the sense about the key ingredients of this model. The first is that labor mobility should be driven by the search for higher wages or higher utilities. This is the first. So we are an economist, and I think that this is really important. Yeah. The second is that there are spatial spillover in consumption and production. If you think about glacier, glaciers, you have an idea of spatial spillover in production, but maybe you know that there are also spatial spillover in consumption. Okay, we use the term maybe not so appropriate of endogenous amenities, just to think about that the population density maybe is a sort of value added also for your consumption. Yeah. Then there is exogenous amenities. It's clear. We are in Italy, we know very well. Yeah. Okay. So which pattern we are interested? The first is the agglomeration of population or productive factors. The second, it's clear, is the wage inequality, but not related to the individual wage inequality in this project, to the spatial wage inequality. Because another things, very important things, is that we observe a lot of spatial wage inequality in Italy. Yeah, it's not just related to nominal wages, also real wages. And maybe we have a model explaining this, yeah, or maybe not, but okay. So here there is a list of literature, okay. If you are interested, I send you that. I think that also maybe I take just a very short list just to give you some references if you are interested, okay. And agglomeration over space, okay, Krugman, Fujita, Etisse, and so on. Agent-based model, maybe just Schelling is Nobel Prize and other things, okay. Spatial externalities in production, spatial externalities in consumption, amenities, okay. Maybe here there is also Alessandra, but maybe okay, it's not here, okay. Cities as a complex system, okay. This is really important. Now we discover why. And the two items, the last two items is just technical references if you are interested to the theoretical model that we'll discuss, okay? I'm not sure that you are interested, but okay. So let me just give you some intuition. Okay, perfect. Okay, just some intuition. And it's just jargon, okay? Okay, suppose that to consider a list or a set of agents. The number of agent is n. Xint, sorry for the n, is what? Is the position in the space x, okay, of agent I at the period t or time t. The Xint is just the change over time. What is the meaning of equation 1? Okay, this is a utility, and this is just the gradient or the first derivative if you are just in a space with one dimension. I use the gradient just because generally we are in 2 dimensions, okay? Just to have an intuition, this is exactly the picture representing the equation 1. Suppose that you are here, they are in 2 dimensions, x1, x2, and suppose that you are interested on the dynamics of agent I when this is at time t, the position of agent I. And suppose that you want, these curves are indifference curve. And suppose also that these indifference curve are utility equal to 1, equality equal to 2, and so on. So this means that I can calculate the direction of increasing utility, okay, in my space. This direction is exactly this black arrow. It's very simple here, no? It's okay? Then, if I have that direction, this means that if I believe that agents are searching for higher utility, which will be the direction exactly this, the black arrow. It's clear that this is exactly typical approach when you are in the agent-based model. Oh, sorry. When you take this, it's clear that you have to consider that this is the direction, but the actual movement can be, for example, limited by friction or cost of moving and so on. And the blue arrow is exactly this. The idea that you can move, but just for a shorter distance. When you take this, it's exactly equation 1. But we take this, but it's important, and this is crucial, that is not just important for your utility, your position, but it's important to the position of other agents in the space. And this is the big issue, the very big issue. When you take this approach, you have not just to take just my position. I need also to look at other people, because it's clear that if you have a spatial spillover in production, you have a spatial spillover in consumption, it's clear that the position of other people is crucial. It's okay? And this is the key point, is the difficulty. When you take the standard approach, for example, for other scholars, or you get a sort of forward-looking perfect foresight equilibrium, and this means that I know everywhere in my space, and I know other things, and then I solve. But is a sort of this procedure is a sort of okay, I can take over other people around me just as a measure, for example, the average price, the average position, and so on. In this approach, you have everything, but it's not optimizing. It's just taking the direction. It's clear or not? The approach? It's really important, because in some sense this is at the base of anything else. When you take this, you have not, okay, in the Peter Howitt words, this means that you lack of coordination, and you have a sort of limited horizon. But this case is not a time horizon, it's a space horizon. In some sense, sorry for this is not completely wrong with this expression, okay? But you have a sort of local, okay, perspective. Yes, please. There is no representative agents here. Agent, no, it's okay, because this is exactly the difference. You have no representative agents at local level and a macro level. All people are different. Yes, exactly. Yeah, it's okay. It's for example, it's quite different if you are familiar with the mean field game. This is not a mean field game. You remember, maybe you know, the mean field game is a typical general equilibrium approach. So you think they're always different, but for you, it's important just the mean. Here you have not this approach. Yeah? And this is the difficulty. And also the advantages. No? Now we will discuss, okay? Can I proceed? Yeah, okay, sorry, maybe. Okay, so very simple. I use a very simple framework. I exclude any savings. So consumption is equal to real wages. Why I take equation 2 explicitly, I define nominal wages and prices, because, okay, in this paper, we have no theory of prices. But because a place of residence, a place of work are the same. But it's possible also to extend the model, and we have a model where the place of residence is different from the place of work. So this means that the prices for you is important for your place of residence, but the wage is decided by the place of work with the different prices. Yeah, so this is not made here. We assume that they're the same. Yeah? But for example, if you are interested to commuting, you have to take these different routes. So which is the definition you use of a utility? Or again, very simple. You have a random utility approach. Maybe you know is the utility is linear in the income. This means that is a sort of indirect utility. Okay, and you have also again as a plus. The endogenous amenities and the exogenous amenities plus a random term. Yeah, the random term is okay inserted, but is not so crucial. So I think that's very simple, and I think that it's very simple because there is a reason. Okay, now we discover why. Okay, this means that the dynamics of individual, it exactly depends on the direction of your utility, but the direction of your utility depends on what? On the real wages around your location. The change in the exogenous amenities, again around your location, the change in the endogenous amenities. Just to be sure, which is the difference between exogenous amenities and endogenous amenities. The difference is that the exogenous amenities depends just on the location you see here. The endogenous amenities depends also on the people around the location. So where other peoples are. Yeah? Think about facilities, hospitals, schools, and so on. That depends on population density. And our measure of population densities is exactly the location of that people. It's clear? Yeah? Okay. If this is clear, maybe this is not so clear. Yeah. Okay. What is this? Okay. You take the equation like this. This is just for one agent, I. You take all agents. The number of the agent is n. You take this, you take the limit of n. Okay, if you are in physics, this is called the thermodynamic limits. Okay, because the number of particles is going to infinity. Yeah, it's a sort of limiting behavior in the number of agents in your economy. And there is a very impressive, to me, result that the dynamics of the mass, this L is the mass of people in location X at the time T, is governed by this partial differential equation. Okay, it's an issue related to the jargon. Yeah, let's just 2 minutes. What is the meaning of this? Okay, this is very simple. This means that the change in the number of people, this is the mass, but the number of people in location X at the time T is proportional to the people in the same location. Maybe you are familiar with the Solov growth model. This is exactly this. Yeah, is the change, the exogenous change in the people of country is proportional to the number of people in the country. These are not so easy. Okay, what is this? This is exactly the very bulk of the problem. Okay, these are again, but it's very symmetric. So it's possible to demonstrate that when you consider the dynamics of the previous equation, and you can divide the total dynamics of the mass over space into 2 main components. The first is called transport. The second is diffusion. This is, I'm sorry, this is typical jargon used in physics. The transport is the idea that you have people taking from one side, one location, and you transport to the other location. And why this? Because they are driven by the search for higher utility. And this part is here. And this part is here, is exactly related to this. It's not strange, but okay, it's strange for the notation. The second part is here, is called diffusion. And which is this? Is the random component. The fact that there are also some random change. Yeah. And the other 2 terms is exactly related to the same idea. So why is so important this? Because it's a sort of aggregated, when you take the Solov equation, for example, you get what? You are not familiar, but okay. You get that you imagine to consider representative agent and to take this representative agent at the aggregate level. This is exactly the same. But it's more complicated because you have heterogeneity in the distribution of the space of our workers, people, population, as you want. Okay. okay? Which is the missing information. Ah, yes, thank you for, okay. Yeah. 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 To the position. Yeah. Yeah. Yeah, there is a part of is it okay. When you take it, this is a very good question. No, it's is a part of the story. When you take the random utility model, is if you are familiar with the McFadden theory of choice, you have two components. The first is a sort of a structural component. For example, you are maximizing your utility, very good. But when you consider individual agents, you have a sort of hidden heterogeneity. And which is the main or the method used for describing hidden heterogeneity? Random term. So this means that you are, take this, you are interested in your wage, but maybe there are some hidden characteristics at the individual level that are taking you from not just maximizing your utility based on wage, but other things. This is exactly the approach. It's a really, I think it is a really good approach. If you think this is a sort of measure of our ignorance in the movement of individual agent, okay, over time. Yeah, exactly. Yeah. So in other words, I think that all movements can be described by economic factors, but there is a sort of idiosyncratic characteristics that is taken, okay, as given, yeah, here. Yeah. This is a part of the story. Yeah. Let me just describe very quickly the local production. The local production, again, here there is the need to specify local production. We have just labor. So this means that we take a sort of the simplest form. The simplest form is the total production at location zeta, sorry, x at zeta. Okay, sorry for the typo, is x, okay? Is the result of two components. First, the stock of labor in the location. Second, local technological progress. LAL, okay? The wage is very simple, is exactly this, okay? Is exactly the total production divided by labor. This is means of -1. And you observe that in this simple hypothesis, you have also a sort of centrifugal force because there are decreasing marginal product to labor. So this means that a density is not good if you take the total production as this and you assume that there is at the individual level decreasing marginal product. It is a sort of force for, okay, diffusion, in other words, or to take a sort of not concentrated people. And this, I think, it's very standard, which is the source of aggregation, agglomeration. They are clearly the positive spatial externalities in production. So this means that are, in our model, modeled by AL. Okay, this is a technical part, but okay, just to take the intuition, you have a sort that increasing the density of population in your location or the neighbors of your location, you increase the productivity of individuals. If you want a discussion, you take the Glaser approach to the cities or other, okay, they are cited in the literature. So the increasing, okay, returns due to the population density or to the agglomeration is a standard, I think. And this is a typical centripetal agglomeration force, sorry, okay. And this is just a technical, this is a kernel, but okay, it's just it's a technical. So in other words, in this model, we have diffusion, okay, transport, and then we have two forces. One is just for taking a flatter distribution due to the decrease in marginal product of labor in the location, and the other is the agglomeration due to the fact that we have positive spatial spillovers. Yeah, please. Yeah. Yeah, okay, in this case, I think that the best way to take this is you have to decide if this is an issue related to the production or to consumption or to utilities. If you take, for example, pollution, where is the pollution here? Pollution here maybe is this, is the endogenous amenities. Okay, because we know that, okay, if you want an hospital, you need a lot of population now in Italy. But it's clear that if the concentration of population is too much, you increase the pollution. And you get your point, I think. And this is maybe is too much. Okay, yeah. Absolutely. The bid for rent is the price. Yeah, exactly. We have no model for the rents here, unfortunately. Okay, just to take an example. This is a simple example. Yeah. Okay, I hope that is more or less clear. Yeah, it's a simple example means that we take out any heterogeneity in the space. So this means that we take out exogenous amenities and also just endogenous amenities, but it's just for an example. So this means that we are considering just this part, this, plus this, okay? Okay, this is a space, okay? Two-dimensional space. We start from, okay, a very flat distribution, and these are after the periods, yeah? What is the dynamics here? The dynamics here is that first you observe a sort of a local agglomeration, you see. This local agglomeration is concentrated in 4 locations. And this means that this is typical, no? When you have multi-center cities and you see that this is not so easy because you see that in the center, you have a sort of small cities, yeah? It's like a small downtown, no? And then at the end of the story, you have just 4 cities, separate cities. What is the point here? The point here is that we have agglomeration. It is okay. But we have a force also for diffusion. And when you take the dynamics, it's not clear, okay, at the beginning, which is the winner. Yeah? In this world, the winner is not existent in the sense that you have a sort of equilibrium between diffusion and agglomeration. And the thing is that this is, okay, here is all is symmetric, but it's possible that if you insert also small random difference in the space, you get the city there. Yeah. In other words, I was fascinated by this because okay, this is a model with 3 parameters, and there is just the idea that workers are moving toward higher wages. Yeah. 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 Representation in what sense? Sorry. Yeah, because, okay, diffusion there is, yeah, there is a part of a random, and then there is the part of a centripetal role. Yeah, it's 2. Yeah, in other words, when you take the partial differential equation, this is a jargon, it is the part of diffusion. But as economists, we have an additional, it is not present in the standard model of physics. That is the marginal decreasing return to factors. Yeah, it's okay. No, it's a very good question because I'm okay. Okay, think about this. Then think about a world where the bandwidth or the range of the spatial spillover is increased. Which is the result? The result is this. The same parameters you observe at the beginning, you see the same pattern, more smoothed. But there is, from this period to this period, a sort of incredible change in the pattern. And then you get at the hand, one big city. Okay, which is my impression? Maybe 2 degrees of freedom, just with the 3 parameters. This is the point, okay? Unfortunately, just 3 parameters and you get anything else, okay? You want one big city, okay. We change the small parameter, 4 cities, okay? And I'm not sure that is a good point for the theory, but, and this is my concluding really sparse comments on this. So we can generate the emergence of different cities with a different shape, starting from homogeneous, really homogeneous situation or distribution. History matters because it's just sufficient, a small wave in this homogeneous distribution, then we get there, the city. There is also another concept I'm really engaged with this. I think also also the innovation theory is the concept of metastability. And which is the concept of metastability there? When you look at this, you observe this. For one period, second period, third period, it's not, we get a sort of more or less a stable pattern. If you are a standard economist, okay, this is the equilibrium pattern. Maybe it's not exactly the equilibrium distribution, but the equilibrium pattern is this. In the same time, because these are equal time, you get a strong transition. It's not a phase transition, because the parameters are constant over time. It's just a transition. So this means that when you take this the distribution of population over time, unfortunately, the spine of your observation is crucial. This is terrible for the empirical evidence. It's really terrible. And so this means that, for example, the approach cannot be based on the standard econometric techniques. And we are working on this. And the concept of metastability is, okay, or punctuated equilibrium, or technological paradigm, if you want, is exactly present here, but is completely dependent on the shape of the process, unfortunately. And this is really studied in the physics, but okay, I was completely ignorant, more or less, still 1 year ago, okay. And okay, finally, we have a strong nonlinear out of equilibrium dynamics. And this is clear, no? Because this transition is really nonlinear. So we have not 4 cities, then 3 cities, then 2 cities. No, you have 4 cities and 1 city. And this is terrible also for the empirical evidence again. Okay. Next step. Okay, it's just okay. And I'm finishing. Oh, sorry. Please. I'm sorry. Yes, no. This is absolutely closed economy. So you have just this economy. Yes. Yeah.
Waves, important waves of migration.
Yeah,
inward and outward,
good point.
Agents.
Migration is here.
Okay.
Yeah,
Okay.
and this is the increasing number of workers in your economy, is NTX.
But this.
But in this simulation is taken equal to 0.
Okay.
This is a good point. But if you increase this, we have a simulation with this, it's still terrible. Why is it still terrible? No, this is still terrible because to this we get this pattern. So you try to increase n from 0 to 0.001. This means that 1% per year, no? And you get a sort of exogenous change. Unfortunately, this change is not neutral because we have centripetal and centrifugal forces, and they are non linear in the mass in the point. I think that it's quite intuitive, no? Unfortunately. So, and this is, you increase the complexity of your landscape in some sense. This is a really good point, but is for, I need to understand well that now, okay. This is a really good point because I think that the migration is really important here because it's clear that if you increase the mass of people, you have an increase in the level of efficiency because you have agglomeration force is driven by spatial, positive spatial spillover. So this means that you can increase the wages. But if you take the dynamics over time, maybe you increase also the wage inequalities. Okay, I have no time to show you that this picture is, there is also a picture with wage inequalities because it's clear that the wage is local wage. Okay. It's very good time. Okay. Yeah.
You want to take another question? Okay.
I think that.
Oh, thanks.
Yeah. Sorry, I take note of the.
So my question concerns exactly how you conceive of search in this model. In an earlier, you commented earlier just in passing, referring to labor market search, and that's a very intuitive idea.
Yeah.
And yet, if I understand the structure of your model, there isn't search in the normal sense. There's just a response to a wage differential.
Yeah.
And they've done all the search instantaneously and are just responding to it.
Yeah. Yeah, you are really right. There is a sort of a local search. Yeah. And in the dream model, there is also this physical capable modality. This means that you have a local search, but the local labor market depends also on the vacancy. In this case, it means the firms going, for example, in location where the wages are lower. And then this means that you are higher return on capital. We have the model with this, but it's really tough. The only thing is that you have a local perspective. We have the possibility to think about that we are searching for different local labor market, unfortunately, because I think it's impossible for in this. Okay, it's maybe it's correct. Yeah.
Okay, Davide. So first of all, let me ask you: Did you complete your presentation?
Absolutely.
Yeah.
Absolutely.
Okay.
Yeah. No, sorry.
Okay. So thank you.
Sorry. This is okay.
We somehow implicitly enter in the discussion phase, but I wanted to be sure that the presentation was over, right? Okay. So having assured that, thank you very much, Davide, for this interesting presentation, which was also the opportunity for our PhD students, I think, to hear about agent-based models, which they do not occur that often here in these places. So we have a sort of tradition that we leave PhD students sort of priority in asking questions if they have, okay? Now, I didn't verify whether we can pick up questions from the Zoom also. Did you check at the beginning? Did someone check? No? So, okay.
Is this, sorry, I'm not an expert of that. Yeah, I think that there are no questions.
Any question from the PhD students on the Zoom, or In case question from PhD students here? No? Oh, Carlos, sorry, I didn't see you.
Good evening, Professor. Thank you. This was amazing in the sense that I don't have all the tools to properly understand the model that you presented, but I was amazed by in the sense that, first of all, it's very also funny to see a different approach. No, I don't know. It was very interesting to see that this brave attempt. The question is not really related to this like research, but I was wondering, since a couple of days ago, I had a conversation with a friend of mine who is from the other part of the world with respect to Italy, and he was wondering the nature of the born of these little villages around L'Aquila. And he was wondering about the role of we were discussing about the role of the earthquake in the process of, empty the city center.
Yeah.
So would it be possible to apply this model on the contrary, like to see when this peak originated in centuries of history, got destroyed by an external input, and how the other little peaks originated around the former one? Thank you.
Very good point. And this is one additional point I miss here. So your point is, which is the memory of shocks? Here is the long memory, unfortunately. And this is exactly the meaning of history matters, unfortunately. So here there are a sort of, this is a general, in some sense, it's a general equilibrium model. In other words, you get a shock at the quarter, and then you have you spread out the people. You decrease the positive spatial spillover, and you increase at the same time the positive spatial spillover of other locations. And there is no mechanism here just to take the previous equilibrium here. It's terrible here. And this is, I think that is okay for the quarter, but think about wars. There is a plant, okay, not the more, okay, the recent war, but I'm not an expert, but I wrote something about social conflict in Africa. It's terrible. It's terrible because if you take a country with a social conflict and, okay, and you take the experience after 40 years, you get again statistically significant negative effect of this war. So exactly this, yeah. And unfortunately, this model is a model in favor of history matters, but it's not a novelty. If you think about the contribution by Paul Krugman or Fujita et Tisse, history matters. And your point is exactly this, unfortunately. So this is maybe also there is the policy implication. It's clear. You have to take action against this natural tendency towards a new equilibrium without people in the downtown of L'Aquila. You know.
All right. Any other question from PhD student again? So next call, sorry, last call for Zoom attendees. Last call? No. So let us open discussion to, say, faculty members or others. So there's Alberto, want to have something?
Yes, thanks a lot for the talk. Very interesting. Thanks, Davide, for that. I've got a couple of questions, and I must confess that I come from a different church. Instead of ABM, I do econometrics. So although some of the dearest friends of mine in academia do ABM, and I always struggle to understand, so apologies in advance. So I guess that my first question concerns the mechanisms that you are investigating here, and in particular, how they work in the Italian institutional setting. So basically, the engine, one of the engine in the dynamics that you observe appears to be the wage. And you say like it's local wage, then differential wages. Fair enough. However, the local market institutions in Italy are super rigid. And I'm not entirely convinced about the possibility to have such a thing like a local wage, because basically the wage is one. For all the Italians, the thing that change is the occupation. And so, like, given your initial statements about your aim to look at local labor market dynamics, I was wondering if you plan, or what could be in your picture, they're all given by, for instance, structural change and the emergence, destroying, or gain of importance of specific occupations. Because at the end, I think that if you don't look at that, what you may observe at the moment is more of a spurious correlation. So you have wage, which drives everything, but at the end, what really matters is the fact that in Milan, you've got people who are engaged with highly paid occupations. And it's not local wage, it's just the fact that you have a bunch of people doing very highly paid jobs.
Oh, okay.
And the second thing that I wanted to ask, again, it goes back to unobserved heterogeneity in my jargon, and randomness or diffusion in yours. And I say, like, to what extent can we be confident in giving, from a logical point of view, in giving, like, to something that we can't really observe, such an important role in your model? At the end of the day, it's true, we always have a measure of ignorance, but in particular, in this particular case, if I understood well, the measure of ignorance is basically everything but wage, in a sense, or like everything that drives the concentration, which not drives the concentration, and it's at the individual level. But at the end, this is very important. And I think it's a little bit of a pity to call it randomness, because there is skills, there is family decisions, there may be sexual orientation if you want. So people decide to go and live in Milan because it's more gay friendly, simply. And it's not like, it's not randomness in a sense. Okay, that's it.
Can I? Okay, perfect. Okay, thank you for the comments. Are very, very interesting. Okay, and I think that. Okay, when you think about first difference in wages, you are right that the nominal wages, is this, are really similar for example, for me and for people working here or in Milan. Unfortunately, the difference here in Italy for these people are in the level of prices. Yeah. So this model, this is the reason because I use R here, is a model with real wages. So just to be sure, from Milan to Palermo in Italy, there are more or less 35% of the level of prices. And this is the first point. I think that if you look at the wages, real wages at the regional level, unfortunately, this means not two level. In Italy, there is big differences. I think that's big difference means 20, 30%. This is also the reason because we have a lot of interregional migration in Italy. Yeah, and also this is a thing that I'm not sure that these differences are sufficient to explain the mobility. Okay, but I think that are not uniform. Yeah, yeah. And this, I think, this a good point maybe is to discuss in more detail about the skills, different skills. Unfortunately, okay, what is the point here? No, when you introduce heterogeneity in skills, you can take again this model, which is the point there. Very simple. You have just not this. Sorry, this equation is the same, but you have here also an additional index for your stock of human capital. Suppose that, for example, you have two different types of agents, high skilled and low skilled. Yeah, which is the point there? And we discuss, okay, we have again another station of the model. we increase, unfortunately, the degree of freedom, which is the point. When you have this, if you consider a homogeneous labor, it's clear. The definition of the definition here of positive spatial externalities, this means the labor productivity, here is very simple, just related to this partial density. It's clear that here we should introduce something about sustainability or complementarities between or among labors with different skills. This is a big issue. So we have a model where, okay, spatial spillover, positive spatial spillover are just related to the high-skilled workers. But at the same time, maybe you want also low-skilled with high-skilled because there is some complementarities, yeah? But low-skilled and the low-skilled are not complements. So this means that you have not spatial spillover. Okay, the evidence in Moretti is not exactly this. Is not exactly this in Moretti. In Moretti, there is something related to the fact that you have hour wages. Identification of the technological complementarities is really strange in some sense. In fact, if you take one explanation of wage inequality is exactly this. Yeah. So we have not a strong complementarity between low skilled and high skilled. And there is a sort of direct technological change in favor of high skilled. Yeah. And so in this case, you should think that this have also an implication for your movement, which is the implication, very simple or not very simple. You have a sort of concentration of high-skilled people, okay, in over space, and the low-skilled are not so concentrated because your additional advantages in terms of positive spatial spillover are not present. This is more or less the point. But I think that we have an explanation, a paper on this, but I think that I'm really impressed by the fact that here we have not the need of heterogeneity in skills for generate this. Maybe something is missing, but I'm not sure. Yeah. This is
right.
Good point.
Any other question? So does Fabiano here? Just hold on. I'm a bit slow because of my.
It's not a question, it's a clarification maybe. You told us that three main patterns arise from your analysis. I was wondering at the very beginning of the lesson, so the lesson, large cities, medium cities.
This.
Yeah, I was wondering about small cities which are located along the Apennines, for instance, which cover 60% of national territory. So a huge portion of our Italy. Yeah. And what about their patterns? Because they have a very peculiar pattern.
Yeah. I'm really not sure of my comments here because, okay, I'm not a demographer. Okay, but if you think about this, your point is like this. You see here, no? These are municipalities with a low density. Yeah. And you see that there is a tendency here in this direction. It's not clear because it's very, very complicated or not chaotic dynamics, but I think that the pattern is this direction. And maybe along this. So this means what? This means that these municipalities are losing or are missing people. Very simple. I'm not sure that, I'm sorry, I'm not sure that this is the end of a story. Is the end of a story in this exactly in this period of observation. Yeah, and this was the reason, because I think that we need a sort of redefinition of municipalities in Italy. Maybe you know that there is a very strong effort, for example, in France, to take action in this direction, because this is an issue. Because we know that the municipalities are really important for the services, for the working of some essential services. And if you take this means that these municipalities are in bigger trouble. And I think that your point, and I suppose, yeah.
Sorry, about the territorial representation of inner areas, there is also a sort of stigmatizing statistic, because of course we know that functional urban areas were created in order to map urban areas, as well as local labor markets were introduced in order to map industrial districts. So we are, I'm going to say, measuring inner areas which have very peculiar and specific characteristic with tools which were created in order to give count of different spatial phenomenon, we can say. So that's another point. It is difficult, I know, because we do not have, in fact, another tool in order to map. I'm trying to. I'm going to publish something about the local system of the Abruzzo region, starting from an original definition. But yes, I guess we do not have something similar at the national level, so we can just use.
Yeah, if you see that here there is a sort of a threshold, no? If you are here in 1982, you're going there. But if you are here, there is a sort of very fuzzy set. But if you are here, it's clear that you stay here or you go there. So there is a sort of a threshold. And this is a part of the story. The threshold is driven by the population density, and maybe from the not strongest positive spatial spillover. This is not strange. No, think about the location of young households with the children. Without schools or without hospital, you change your location. So it's so trivial, unfortunately. Yeah. No. Okay. Sorry.
Right. Any other question? I got a clarification question, Davide, about the way in which local technical progress is dealt with in the model. Did I get it well? I'm not sure whether I got it well. Is there any proper endogenous force within the location that drives technical progress? Yes or no?
Yeah.
And which one is it? Because you said that basically is driven by, if you go back to that slide.
Yeah, exactly. Maybe the best is to look at the slide. Yeah. I'm sorry.
So what you have here is actually weighted sample workers around location X.
Exactly.
Correct?
Exactly. This WH, sorry, is a sort of aggregation matrix, but it's in continuous space. It's not an aggregation, but it's an integral, but it's the same. It's called the kernel, but okay. And you take a sort of sum of your neighbors.
Okay.
And age is exactly the radius of your aggregator.
Okay.
The aggregator depends on the shape of W. So this means that you can have aggregator that you have a sort of very declining with the distance. Okay, sorry, because it's
okay. Okay. So basically, you have locus X, and you get basically
exactly
the radius around X.
Yeah. Just to be sure, it's possible also to define this aggregator also not in the space, but for example, in space, in the geographical space, but for example, for different sectors.
Okay.
So we can define also a dynamics in different sectors. So we change the space location, but also the sector.
Right.
So it's possible to extend. We have not, but just
You
to be sure.
You
Okay.
just have one industry. at the
Yes,
moment.
exactly. It's sectors or industry. Yes. Okay.
Okay, you just
Yeah.
have one industry.
And so to define the spatial spillover within the same industry and not just space, just to increase, I think, the likelihood of our description, because,
But
okay, it's good that it's important also the type, no,
Okay.
of industry.
So what
you
you're
consider.
saying that you could even stretch the model for including spillovers across industries?
Yes, exactly.
You can do
Or
that.
you cannot. We can, maybe you have a sort of agglomeration, but in a specific industry.
Okay.
Just how is possible here to look at a discrete industrial district?
Yeah.
Exactly,
yeah.
specifying WH not just for individual in the space,
Yeah.
individual in the space, but also in the same industry.
All right. Okay.
Yeah.
And then, okay.
Yeah.
Then you get, okay.
You have a sort of
That could be interesting because actually
Yeah.
you can actually
yeah.
capture different kinds of locations.
Yeah.
right? Okay.
Is a sort of a system of a partial differential equation where you have, for example, L industry, and you specify the industry.
Okay.
And it's incredible. It's not difficult here, but okay, it's very powerful. This.
Yeah.
Yeah.
Okay. Yeah. I don't know if there are no other questions. I think that we can close the seminar. We thank you again very much,
you.
Davide. And I think that as usual, if some of us is interested in knowing, some more detail about the model, you can write an email to you.
Absolutely. If you want the, unfortunately, this is very big, so I send you, maybe if you're interested, the link in Dropbox, because it's I'm really happy to discuss with you, okay? Because I'm really interested to also because it's a very novelty for me, this approach. I'm not an expert.
You are.
Yeah. Okay.
Okay. Thank you very much, and see you soon. Maybe after Easter for other interesting seminars / webinars. Thank you very much for having come. Ciao.
Grazie a tutti. Thank you.